clean energy. So all these topics might be addressed, and this is what we discussed today. What I should also mention is that the German-Russian cooperation network is supported by Bayer Technology Services and Devonik. They have special interest in building partnerships here to Russia, and of course by the BMWF and the North and Northwest Paper. Well, here's some idea about the bioeconomy in the European Union. This is already 17% of the gross domestic product. 17%. In sometimes very traditional sectors, food, 47%. Agriculture, 19%. Pulp and paper, 18%. Forestry and wood, 13%. Chemicals, 3%. And here I have estimated the content of, or the contribution of industrial biotechnology in amino acids. It knows that 100% biotechnology, adhesives 40% by biotechnological methods, 60% by chemical processes, and so on for all these groups. So this means the chemical industry depends mostly on fossil carbon sources, but there's already a lot of use of renewable carbon sources. Hi. In Germany, we have since 2 years the Bioeconomy Council. And the last report from them, and this one, was published in May 2011. And Professor Hüttel, who is the chair, he starts in his introduction with the following: one of the greatest challenges of our time is to produce sufficient volumes of biomass while maintaining a sustainable approach to our terrestrial and aquatic resources. Only by considering all aspects of sustainability can we secure food and at the same time ensure that there is sufficient biomass for material and energy use. I think this brings to the point what we are speaking about today. Food, materials, and energy, but food must have priority. We must have something to eat. Now, if you look on the basis of production of biomass, we speak about agriculture and silviculture. The basis is soil. We speak about industrial processing of these products, and chemical and biotechnological production. And we speak about water, fishing, and agriculture. Today, I think we should focus here on soil, and silviculture, and chemical and biotechnological production. And if you look now on the products out of these fields, these are here very general. Plant and animal products, and from that are produced paper, chemicals, textiles, 2 times chemicals. Food should be here, cosmetics exclusively, I did it in the aircraft. And biofuels are produced, biogas, bioethanol, maybe more in the future, biobutane. In Germany, I think this is a number I was astonished about the dimension. 20% of agricultural materials are used for energy, and 43% of forestry materials are used for energy production. So this is the dominant use. The basic processes we need for that are biotechnology, chemistry, and processing. Now, and I will now go through these different sectors and will try to give some ideas where we should find possibilities for joint projects. Agri and silviculture means input sector: seed, soil, plant protection, machinery instruments, feed for husbandry, veterinary products. In the agri and silviculture, we need arable farming, pasture management, greenhouses, storage and logistics, production of animal products, and forestry. These are out of these input sectors the output, if you will. We need processing technologies, processing raw materials. This is what we speak about, this glucose transforming, for example. We need machinery and instruments, storage and logistics, and food and drinks processing. To give you an idea about the global economical volume, seed production, $37 billion, fertilizers even more, 85 billion, plant protection, 40 billion. So there's a lot of business behind these products. Next, please. Now I will go through these different sectors. If you look on seed, plant breeding input and output traits are very important. Soil quality, soil characteristics, fertilizers are maybe a topic. Plant protection, resistance, tolerance, protective actives. This is also part here of these input traits. Machinery and instruments, we might need more monitoring systems, more customized fertilization. I mean this that we at first analyze the field and then decide how much fertilizer does it need, and not just take 2 kilo per I don't know what. Feed digestibility might be still an issue. Nutrient recycling, I will come to that. Veterinary measures, animal health in general, vaccines. Here also some numbers out of this bioeconomy report. Cereal production, we need till 2030 a plus 50%, to 2050 70%. Animal production is expected plus 100% till 2050. And if you know that most of our agricultural land is used for animal feeding, this is a real issue. Next, please. Well, I tried now to give more details. If you go to input traits, this might be resistance against pathogens and pests, tolerance of heat, cold, and salinity, optimized water and nutrient requirements. Phosphorus, for example, everybody knows, is by midterm limited. We don't have it unlimited. It might be possible to transfer the nitrogen fixation system from legumes to other plants. I know that there was a long tradition in working on that, but there's still no real solution. And for example, reduce methane emission of rice culture, which is a climate motive. Output traits, biomass and fruit yield, this is very general, improve the biomass yield. There might be an improvement in products like flavors, vitamins, antioxidants, fatty acids. It might make sense to increase the trace elements, for example, iron and zinc, and also to reduce the accumulation of hanging metals. We might influence that by biology. And just to give some keywords, which technologies are needed. Non-invasive phenotyping platforms is one possibility. For example, Professor Schoen, we'll meet him in July. He builds up such a phenotyping platform. Marker or sequence-based breeding for seeds. More complex expression systems are needed. Synthetic biology is a very general word. And of course, bioinformatics, and I know that already this between Bielefeld and Novosibirsk and corporations many years in this field. Next, please. If you look on the next input sector, the soil, the microbial population in soil might be a topic. I know that a few weeks ago when we visited St. Petersburg, the Institute on Microbial Population in Soil, they just celebrated their 125 years celebration or something like that in anniversary. It might be possible to optimize the water storage capacity in soil. The problem is the emission of nitrous oxide for microbial conversion of fertilizers. There might be also a solution by biology. And many people speak about using soil as a carbon storage by charcoal. So here, the Bioeconomy Council, the German Bioeconomy Council, recommends to systematically record genomic data from various habitats. There is not enough knowledge about that. To build metagenome banks from different fields and soils, and again, bioinformatics plays here a crucial role. Next, please. Feed digestibility. You know that, for example, phosphorus is difficult to digest. If I think about phytase usage, So it might be possible to adapt the feed quality by breeding, adapt feed plants, develop more feed enzymes and additives. Additives are amino acids, but there might be more which might be helpful. Some of the feeds are lost in manure. There might be a topic to recycle that. And reduce methane emission from beef cattle farm. This means targeted plant breeding. I spoke about that. Identification and production of enzymes and additives. And in this field here, optimize the rumen microflora. If it comes to veterinary measures, vaccines, to use vaccines is already known. Keeping of animals might be optimized. Pathogen resistance. This is just at the moment a big discussion in Germany. You might have heard about the E. coli epidemic in Germany. So far, 39 people died because of EHEC on vegetables. Nobody knows the source so far. It might not come from animals, but this might be a bigger problem in the future. So we have to hear veterinary measures. This is a real field. Identification and production of vaccines might be a project. Improved animal keeping and identification of new breeding targets. Next, please. Greenhouses. I think we should be open not only to speak about specific biotechnological topics, very highly sophisticated like synthetic biology. I think also in some other mechanical and monitoring systems is still improvement. For example, in greenhouses. This might need also to use industrial side streams, heat, CO2, water from other industries. It might make sense to develop more monitoring systems. We will therefore visit in July also Professor Schur once again because he's a specialist in building such very high sophisticated greenhouses. And we have also industries behind that in Germany. Well, and storage is also a big topic, pest resistance, pest protection, storage facilities. Also here, oil engineering is asked for. This is also in this field, I think, an important topic. Again, breeding targets, plant breeding, development of protective actives, and energy. And third is the processing sector, processing of raw materials. We might speak about enzymatic treatment. Akali is here the specialist in this field. Use of lignocellulose for sure, extract, and what also might be a topic, extraction of special compounds. So this means identification and production of enzymes and of suitable compounds, and we will learn from Corinne today also a completely different method of processing biomass for industrial uses. Processing of food, the target should be the nutritive value, the quality for the metabolism, the shelf life, slash storage, and it should be free of pathogens. Again, here we have this E problem at the moment. Specific enzymatic treatment might be a solution. Improve of metabolic efficiency. I think there are on the market many products targeting the metabolic quality, but sometimes the efficiency is doubtful. It might make sense to study more packaging and storage technologies. And in the case of freedom of pathogens, lean processing might also be a topic. Well, this is my last summarizing slide about partnering options. When I summary here in production of biomass, seed breeding, soil treatment, culturing of plants, greenhouse, for example, harvesting technologies, monitoring and analytics might be the headlines. And if we speak about conversion of biomass, biocatalysts, on-site biomass processing might be sometimes too expensive to collect all these low-density materials to one site. It might make sense to speak in Germany with CLIB, which is a global player in harvesting machinery, to speak about on-site biomass processing. Machinery and instruments is the same field. And the targets are food and feed. materials, and energy. Thank you very much.
Mm-hmm.